So today we're talking about linear equations in two variables. So for example, if we have to tell whether the ordered pair is a solution, tell if the ordered pair is a solution. You're given the equation in two variables, 2x minus y equals 5, and you're given the ordered pair 1, negative 3. Tell if the ordered pair is a solution. What do we have to do? What does 1 represent? And what does negative 3 represent? Y. So in order to tell if it is or is not a solution, we have to substitute into the equation. We would say 2 times 1 minus negative 3 equals 5. 2 times 1 is 2. Negative times negative 3 is plus 3, which equals 5. Is this true? 5 equals 5. Because we see that the equation is a true equation, this ordered pair makes the equation true, or it produces a true statement, then yes, it is a solution. Let's say we have the same equation in two variables, 2x minus y equals 5, and we have the ordered pair 4, 7. Tell if this ordered pair is a solution to this equation. What do we have to do? Substitute for x and y. Is this true? No, 1 is not equal to 5. Then no, 4, 7 is not a solution to 2x minus y equals 5. So if we are asked to graph an equation, if we have to graph y equals 2x minus 1, we have to come up with a table to find the solution. So we're going to create an x and y table. This space right here, I'm going to rewrite my equation, 2x minus 1. I am going to choose values for x to find my new values for y. We can choose any numbers we like. I'm going to choose numbers that are close to the origin. What is the origin? 0, 0, right here in the middle. Let me label my x-axis and my y-axis. So I'm going to choose, let's say, negative 2, negative 1, 0, 1, and 2. These values that I've chosen for x, I'm going to substitute in the equation. So we've got 2 times negative 2 minus 1. What's 2 times negative 2? Negative 4. And negative 4 minus 1? Negative 5. Going to do this again. 2 times negative 1 minus 1. What does that equal? Negative 2 minus 1, negative 3. We're about 2 times 0 minus 1. What does that equal? Negative 1. What about 2 times 1 minus 1? What about 2 times 2 minus 1? 3. So what happens now is that we can make our ordered pairs out of the x and y values. So my first ordered pair would be negative 2, negative 5, negative 2 from here, negative 5, negative 1, negative 3, 0, negative 1, 1, 1, 2, 3. Yes. What do we do next? We're going to graph our ordered pairs right here in purple ink. So let's go and graph negative 2, negative 5. Negative 1, negative 3. And we can connect our points. If we need to graph y equals 2x, first we need to create our table, our x and y table. At a minimum, we need 3 points for our line. Well, 2 points make a line, but we're going to aim for 3 points. So let's choose, for example, negative 1, 0, and 1. We're going to substitute into 2x. So here we go. 2 times negative 1 equals what? Negative 2. 2 times 0 equals what? 0. 2 times 1 equals 2. What are our ordered pairs now? Negative 1, negative 2, 0, 0, 1, 2. Now I'm going to graph these ordered pairs. Negative 1, negative 2, 0, 0, 1, and 2. And we connect our dots. If we have to graph y equals 3, do we have any x? No. The graph of y equals 3 is a horizontal line through 0, 3. So I go to y3, 1, 2, 3, and I create a horizontal line through 0, 3. So let's say I want to graph y equals negative 4. What would that line look like? It would look horizontal, and it would pass through where? 0, negative 4, or negative 4 on the y-axis. This would be the graph of y equals negative 4. Let's say we have to graph x equals negative 2. We need to graph x equals negative 2. The graph is a vertical line through negative 2, 0. What do the arrows on the lines mean? That it keeps on going in both directions. So let's say we have to graph x equals 3. What would the line of x equals 3 look like? A vertical line that goes through where? Through 3, 0, or 3 on the x-axis. So a function whose graph is a non-vertical line is called a linear function. When the equation of a linear function is solved for y, the equation is in function form. So for example, if you're given an equation that looks like this, is this equation in function form? Is it solved for y? In other words, is y by itself? No, but can we change it? Yes, this is not in function form. So to change this to function form, we need to have y by itself. It means we need to subtract 3x from both sides. And we get y equals negative 3x plus 7. This is now in function form. Let's try another one. Let's say we have x plus 2y equals 6. Is this in function form? No. How do we change it to function form? Subtract 2y? We want y by itself, so I subtract x from both sides. 2y equals negative x plus 6. But is y by itself yet? No. So that means we need to divide by 2. What we do to one side, we do to the other. So y equals negative 1 over 2x plus 3. So I divide the coefficient invisible 1 by 2 and I divide 6 by 2. Now that we have the equation in function form, right here, can we graph it? How would I graph it? To graph this equation, don't I have to create my table? Yes or no? Okay. Now, because I have a fraction in front of x, the easiest thing to do is to actually use multiples of 2. So, I have to use, for example, negative 2, 0, and 2. If we substitute into 1/2 x plus 3, I would substitute negative 2, then I would substitute 0, and I would substitute 2. Once I find my values for y, can I now graph? So the only thing you have to do is find your values for y, create your ordered pairs, and you're ready to graph.